Welcome to Steril-Aire, the innovator and world leader for air conditioning UVC, providing energy savings, automatic coil cleaning, condensate recovery, and IAQ.
IQ? Of course I know what that is. Mine's like 160, Mensa.
Indoor air quality.
Yeah, exactly. Ours is great. No one's ever dropped dead in our building. Well, not from IAQ. It was a holiday party. Anyway, why spend more money?
We clean our coils every year. And you're saying that a blue light with invisible UVC rays will clean the coil year round, improve thermal comfort, and save 10 to 20% of our AC energy costs? Get out of here.
Remove all the frozen food just to clean the coils? No way! Anyway, mold won't grow in the freezer.
You're telling me that our 250 tons of air conditioning is producing 6,000 litres of usable condensate a day? That's 1,580 gallons. And we throw it away just because of the mould and pollution in the coil and drain pan? See me in my office.
There's nothing we can do to stop the spread of colds and flu. Our janitor blames the AC and he cleans it once a year. Nearly everybody gets sick.
Yes, the USA Center for Disease Control and Prevention reported that each year 1,700,000 patients acquire infections after entering US hospitals, and of those 99,000 die. But not in our hospital. We have HEPA filters. And anyway, infections can't be transmitted through the air.
These are the typical reactions of people when they first hear of Steril-Aire. We have been in business since 1994, and our 160 worldwide distributors have thousands of satisfied customers who have tested and benefited from Steril-Aire's UVC emitters. Our distributors have created numerous case studies covering multiple industries, including hospitals, offices, shopping malls, hotels, casinos, airports, education facilities, supermarkets, residential, ships, oil rigs, museums and archives. In fact, everywhere air conditioning is used. Significantly, ASHRAE has incorporated UVC into its handbooks and is developing standards. In addition, the US government's General Service Administration, the Centre for Disease Control and Protection, the Italian Department of Labour, Singapore's Green Plan, the Green Building Council, Chile branch, and the British Navy all recommend or use UVC. By positioning Steril-Aire's high-output UVC emitters at the coil, one can eliminate more than 99% of all virus, bacteria, and mold travelling in the air. Steril-Aire also eliminates the mold and biofilm growing on the coil and therefore prevents mycotoxins and spores from reproducing and spreading sickness and headaches. Whatever your industry, you can benefit from Steril-Aire. Save 10 to 20% of the AC energy cost, eliminating coil cleaning, with payback often under 1 year. Improve sustainability by recycling the condensate. Provide IAQ from the AC system 99% free of virus, bacteria and mold. Air conditioning has allowed us to live and work in extreme environments. The AC industry has successfully developed IAQ standards for dust particulates and CO2. Most buildings claim that they provide quality indoor air, but the World Health Organization, the US Environmental Protection Agency, the Hong Kong government, and many others all warn about the dangers of poor IAQ from air conditioning. The US government estimates that businesses on average lose between 14 and 15 minutes per employee per day through poor IAQ. The Fiskin-Rosenfeld study calculates that poor IAQ cost US businesses $70 billion per year. Most people would be horrified if they could actually see the toxic cocktail of microorganisms living in air conditioning. Historically, we have felt protected because of the misunderstanding that viruses and bacteria are not distributed through the ducts. Legionella and SARS destroyed this myth. On June 24, 2009, ASHRAE's Board of Directors issued a position document indicating that the AC system distributes viruses. This has been confirmed by medical studies, including a recent one for norovirus. Hospitals feel protected by the use of HEPA filters that block up to 99.97% of particulates. However, 1 cubic foot of air typically contains 100,000 microparticles. With air travelling at approximately 800 feet per minute through a 24-inch square duct, we have 80 million particles. So, on average, 0.003% or 24,000 of the particles per minute might break through the HEPA filter. If only a few microorganisms break through, they can infect the patients. There are 4 fundamental sources of pathogens in buildings. First, bacteria, such as Legionella, that enter the building from the outside through the make-up air. Second, bacteria and virus, such as tuberculosis or flu, that are carried into the building by people. Once in the air, the microbes are distributed throughout the building via the AC ducts and pass easily through the primary filters and cause mild flu or more serious illnesses. Third, and the most serious cause of poor IAQ, are mold and fungi that grow in the coil and drain pan. Consequently, the mold's mycotoxins and spores are distributed throughout the building, causing asthma, allergies, tiredness, headaches, flu-like symptoms, and poor productivity. Fourth, the mold that grows in the coil becomes the anchor or biological primer. This allows the dirt that passes through the filters to stick to the coil fins, forming a complex biofilm that produces and releases infectious microorganisms such as MRSA, Pseudomonas, and Aspergillus. These are also distributed throughout the building. The purpose of the evaporator or cooling coil is to provide thermal comfort in a building by removing the humidity and heat from the building's air. The cooled and dried air is circulated around the building by a large fan and is then sucked back to the air handler along with the warm and humid byproducts from the people in the building. A percentage of fresh air is then added. This mixed air is passed through the primary filters to remove big dirt particulates. The resulting condensate in the cooling coil is drained away to the sewer. The heat from the building's air is absorbed through the coil fins by a cold liquid, typically chilled water, that is being pumped through the coil. The heat is then transported in the water back to the chiller. The chiller has a compressor that initially squeezes gas, turning it into a liquid that then passes through an expansion valve, returning it back to gas and making it cold. The cold refrigerant gas absorbs the heat being carried in the water coming from the cooling coil. This chilled water is then returned to the coil. There is a separate water circuit that collects and removes the heat absorbed by the compressor's gas, which is then sent to either a condenser coil or cooling tower. In either case, the heat is transferred from the water into the air, and the resulting cooled water is pumped back to the chiller. The metal fins of the coil are typically made of aluminium that have a heat transfer efficiency of 200 watts per meter Kelvin, whereas the biofilm that often covers the fins may be 0.2 watts per meter Kelvin, or approximately 1,000 times less efficient. According to the California Society for Healthcare Engineering, it only requires a 1.5 millimeter fouling on the coil fins to reduce the coil's efficiency by 16%. When particulates pass through the primary filters and settle on the coil, we should expect the condensate that is produced when the warm air meets the cold coil to wash the particulates down into the drain pan, as easily as one washes mud off a car. But the dust stays on the coil and often requires harmful chemicals to remove it. We now know that as soon as the condensate is produced, mold and biofilm start growing. Mold takes 4 to 6 hours to double, so it can easily multiply into 1 billion organisms in 12 days. As long as it is alive, it will cling to the coil fin. Its sticky surface attracts and holds the dirt onto the metal, forming the biofilm. The biofilm reduces the heat transfer function of the coil, and consequently, the air is not cooled sufficiently, nor is the humidity removed. To achieve the desired thermal comfort, either the occupants alter the thermostats or the maintenance department adjusts the chiller set point. In either case, this increases the electrical consumption of the chiller and pumps. In a typical office building, the AC system uses 60% of the building's energy, and of this, the chiller and pumps consume 70%. The 2006 ASHRAE published study estimated savings of 15 to 30% from clean coils. Steril-Aire's emitters continuously clean the coil fins by destroying the DNA inside the microbes. Once the DNA is destroyed, the microbe can neither grow nor duplicate, so it dies. The dead mold falls away with the dirt and is washed by the condensate into the drain pan. The biofilm growing in the ducts also dies, once starved of its food source growing on the coil. The result is superior IAQ with a reduction in staff sickness and absenteeism, often by as much as 25 to 50%, and an incredible reduction in hospital-acquired infections. One neonatal peer-reviewed study shows that after an investment of only $30,000, there was a drop in infections of 40%. Annual savings from antibiotics, lab tests, doctors and nursing costs of an amazing $800,000. The hospital had an extra bonus of shorter patient stay and greater bed availability. Steril-Aire has numerous examples of energy savings of between 10 and 20%, with payback in 1 to 2 years, and in some cases, even faster. The efficiency of the coil can easily be measured by checking the delta T of the coolant entering and leaving the coil. Before Steril-Aire, the chilled water supply temperature was 6.6 Celsius, and the return 9.8, with a delta T of 3.2. After Steril-Aire, while keeping the same inside temperature and humidity, the supply temperature was raised to 8.5, and the return was 13.6, with a delta of 5.1, an improvement in coil efficiency of 21.1%, as proved by the Singapore Parliament Building Study. A simpler way of verifying coil improvement is with contact plates that provide quick visual evidence of the presence of mold in the coil and ducts, as well as the verification of its removal by Steril-Aire. When correctly placed by the coil, Steril-Aire's emitters will eliminate by more than 99% the microbes travelling from the AC into the room spaces. This can also be verified by checking for bacteria and mold with an air tester, positioned at the room air supply duct. Typical examples were taken before Steril-Aire and after Steril-Aire. Once the coil is free of biofilm, the condensate is also clean and can safely be used as grey water for cooling towers, landscaping and toilets. 250 tonnes of air conditioning, 100,000 CFM can produce a lot of water. In fact, the AC industry is one of the world's biggest water producers. A caution is necessary. Not all UVC is created equal. The output of UVC is invisible microwatts and is not always proportional to the watts coming from the electrical supply. The USA EPA Homeland Security test shows that Steril-Aire's output on a dose per watt basis far exceeds that of the competition. along with a number of independent tests. In order to have sufficient microwatts to kill both the mold growing in the coil and the microbes in the air, Steril-Aire recommends at least 750 UVC microwatts at any point on the coil face. Without maintaining these standards, the people in the building will remain vulnerable. To maintain a minimum UVC dose on a new coil and to keep the coil clean, we recommend using one horizontal row of Steril-Aire across the full coil face for every 76 centimeters of vertical coil height. In hospitals and existing coils, use one row every 60 centimeters. For bigger coils, add rows and emitters. Steril-Aire's system-engineered, high-quality UVC family of products can be installed in the largest AHUs or the smallest splits and cassettes. Steril-Aire's double-ended DE systems are installed inside large to medium-sized AHUs. The SE single-ended and SEN NEMA 4 units are installed from the outside of the AHU through a hole drilled in the AHU wall. The kits for air handlers and unitary units are installed inside the air handler. For ease of DE installation, we provide rapid install modular framing systems and the FIT, Fast Install Tower. Steril-Aire has emitter tubes from 18 to 158 centimeters. The handheld sterile wand is used for surface decontamination, and the portable RIDS unit decontaminates infected areas. The ceiling-mounted units help reduce contamination in ORs, ICUs, isolation wards, laboratories, and clean rooms. Sterile Zone removes airborne contaminants. For water applications, use the hydro-submersible and waterproof units. Steril-Aire's refrigeration unit has been tested to function below -30 degrees Celsius. Food processing is increasingly benefiting from Steril-Aire by minimizing the contamination risk and extending food shelf life. Whatever your industry, you can benefit from Steril-Aire. Take the next step and achieve real and proven sustainability, lower costs, and increase your profits. Most importantly, deliver great IAQ. Call your local Steril-Aire distributor or contact Steril-Aire via phone, email, or the web.